All right, lesson 129. I think the biggest takeaway out of this lesson is going to be conduit fill. I think we've touched on this a little bit in the past, but I just want to really reiterate it. It is an important skill and ability that we all need to know how to do. Essentially, we're talking about how many wires of any particular size can I fit in any type of conduit, okay? So there's two main tables you're going to be concerned with here. First off, Chapter 9, Table 5 in your NEC. You can see here it's page 684. So a couple of things to highlight on Table 5 here. This is basically going to tell us everything we need to know about whatever type of wire we are using when it comes to size. So you can see on the top here we have the column headings are type of wire, so that's going to deal with what type of insulation we're using. Then we have the size of wire in American wire gauge or KC mil, so that's where you have your number 10, your number 12, number 14, your 250 KC mil, 500 KC mil, 1/0, 2/0, 3/0, 4/0, whatever it is. Then of most interest to us for this particular task is approximate area. So you see they show that in millimeters squared and inches squared. Again, we're working in inches squared here. You could theoretically use this. I don't know why you do that, but so we're particularly interested in this inches squared column, approximate area in inches squared. Then they also give you the diameter. Quite frankly, I don't think I've ever used that column, but those are the various columns we're dealing with. Then on the sort of left-hand side, you can see there's all different insulation types here. And this is actually a multi-page table. So you'll notice you don't see type THHN on this page. This is only the first page of the table. So this table's 4 or 5 pages long. So be sure you're using the right type of insulation for the actual wire you're using. Again, in most cases, we're going to look at THHN. But anyway, they have every type. So make sure you're in the right section for the right insulation. And then the last column I want to highlight here is just the size column. Again, that's in AWG or KC mil. So that's going to translate a wire size of whatever you're using to an actual area in inches squared. So the next table, this is kind of a two-part deal here, is Chapter 9, Table 4. So it's actually just a couple pages before Table 5. Again, this is just one snippet from the table. This, again, is a multi-page table. But Table 4 is going to tell us everything about the particular type of raceway that we are using. So first off here, this particular one deals with EMT. There is a specific section for every type of raceway. For PVC, Schedule 40, Schedule 80, for rigid metallic conduit, for any type of raceway you can think of, there is a table for it and specific to it. So once again, here across the top, you're going to see a lot of different information here. So your headings are metric designator. Again, we're not really concerned with that. Trade size. This is your 1/2 inch, 3/4, 1 inch, 1 1/4. Then you're going to see these different sections here. So we have over 2 wires, 40%. We have 60%. We have 1 wire, 53%. 2 wires, 31, so on and so forth. So what are they talking about? Well, basically, if we are pulling over 2 wires, which 99% of the time we are, we may only fill that conduit up to 40%. So what that's telling us is they've already figured 40%. This column here is going to represent 40% already. So we don't need to take what's there and only take 40%. You can go right by what's in this column, but they're telling you that only represents 40% of the conduit. It is interesting why when we have 1 wire and 2 wires, it just doesn't seem rational here. And quite frankly, I don't know. I don't have an answer for that. But again, 99.9% of the time, you're always in this 40% column over here. Again, be careful, millimeters squared versus inches squared. Right. Then you're going to see kind of on the left-hand side, again, we have trade sizes. And then, again, over 40% in inches squared. Okay, so the process is basically going to be figure out how many square inches each wire is, add them all together, see how big of a conduit in inches squared you need to fit that many inches squared for your wire. So we'll go through an example here. So let's say in this case we got to pull 3 number 2 AWG THHN wires, 1 number 4 THHN, and 1 number 8 THHN. So the first thing we got to do to determine what size conduit is, let's go back to our friend Table 5 here, okay? As I said, there is a section for THHN. Make sure you find that section that matches your actual wire. see actually how many square inches does a number 2 actually require here. So we find number 2 in the wire size section. Let's go ahead and check the inches squared column here, the area in inches squared. We get 0.1158 square inches. So of course we have 3 of those. I'm sorry, we'll get there in a moment. So number 4 is going to take, if we look across here, 0.0824 square inches. And then let's check for our number 8 down here. So again, we find number 8 in the table, and we see that that takes 0.0366 square inches. So now, of course, since we have 3 of our number 2, we need to multiply that value by 3. And the rest will only have 1, so naturally that just is going to multiply by itself, or by 1. So what we have now is this is how many square inches we need for each of these wires in total. So our next step here, let's just go ahead and add all those values up. So all those wires lumped together are going to require 0.4109 inches squared, a conduit that can contain at least that many square inches, right? So let's kind of save that for now. We're going to need to come back to that. Let's check table 4 now at this point. So again, we need to check the over 2 wires column in inches squared, right? So we're going to come down in the table and see which one of these sizes has enough square inches to contain our 0.4664, and we see here that it's this one that is 0.598. If we went to this one, 0.346, we'd be a little under. So of course we check that, it comes to 1 1/4. So we're going to need an 1 1/4 conduit, EMT in this case, to contain these wires. So there's not really much more to it than that. You know, whatever examples they throw at you, they all kind of fall under that umbrella. Again, very important skill. One word of warning, this is one place where I think the code book is a little lacking. In other words, just because your calculation says it will fit, if you have maybe a lot of bends, a long run, maybe you're very close to the limit, I highly suggest you go up one side. You're going to find very quickly, and if you've ever pulled wire, you can start to imagine some of this. Even this example in an 1 1/4 conduit, to me, I'm thinking, gee, that's going to be really tight. So again, for any textbook examples, go with what the math says. But in the field, you may want to consider applying some common sense here and maybe increasing by a size if it seems appropriate. So anyway, conduit fill, make sure you guys are up to speed on that.